So now it is time to introduce 4 of the 12 startups that were selected as part of the second cohort of the LH Accelerator on the topic of obviously the future of concrete. So we are thrilled to welcome today 4 speakers from Green Basilisk, Prebona, Sonocrete, and Anomera. So here's how the session is going to go. Each of them will have 4 minutes to present their company. So it's relatively short, but the idea is just to give you an idea of what they do and for you to decide which Innovator demo room you want to join after this session. So listen to these presentations closely. You will have, as Julia said, 2 opportunities to join Innovator demos. So you will have to choose 2 of these 4. Yeah, I guess listen closely and choose wisely. But after we finish this rapid round of presentation, we'll have a Q&A session. I see more and more questions in the chat, and so hopefully we can get to a few of those in the Q&A session. All right, so hopefully we are good to go. I will ask our first presenter, Jordi, to come off mute. Jordi, can you hear me okay?
Yes, I can hear you.
All right, the floor is yours, my friend.
Thank you. Yeah, thank you for having me, first of all. My name is Jordi Kern. I'm a product manager at Green Basilisk. And today I would like to go briefly into who we are, what we do, and what we have achieved during the LH Accelerator project. So we are Green Basilisk, and we offer a self-healing concrete technology based on bacteria. At the moment, we have 3 commercially available products based on this technology. And we've been founded in 2014 and started our first commercial and pilot projects in 2016. The technology has been developed at the Technical University of Delft, and we have 4 active patents. So how does this technology work? But better yet, maybe let's start with why we need it. One of the properties of concrete is that it may crack. In itself, not a big issue. And actually an accepted phenomenon. However, in situations where water can penetrate the cracks, it may result in serious leakage and corrosion of steel reinforcement, which in long term may cause serious durability issues. Well, that's where our self-healing technology comes into play. By incorporating bacteria and nutrients into the concrete, we introduce an autonomous repair property. When in contact with water, the bacteria become active and will convert available nutrients into calcium carbonate, also known as limestone. That limestone will precipitate on the crack wall and will gradually block and seal the crack. This will prevent further leakage and will provide protection to the steel reinforcement. Our technology can be implemented as a repair system for existing structures or as an additive for virgin concrete applications. For the repair market, we have developed a mortar with high deformation capabilities and repair system for impregnation of porous surfaces and cracks. Within the LH Accelerator program, we have decided to address the repair market with Sika because this fits their business in specialized concrete repair products. With LafargeHolcim, we focused on the opportunity for the concrete additive, Basilisk healing agent, which is already commercially available and has been granted the CE marking over the last year. So for the repair market, we focused on our product liquid repair system ER7. And the main objective was to establish a technical benchmarking where we have looked at the crack sealing properties and the surface protection properties. The results indicate that there's definitely a place for Basilisk ER7 in the current market. And especially the results of the surface protection property become interesting for CE marking as well. Furthermore, we investigated the opportunities for the French market and the crack repair application. We have estimated a market of about 1,000 kilometers a year. And also for concrete protection, there's a huge opportunity in civil and industrial market. For the virgin concrete application, we looked with LafargeHolcim. We focused on our Basilisk healing agent additive, and especially we focused on our value proposition for shrinkage rebar reduction for watertight applications. Our claim is that it is possible to accept bigger crack widths due to the self-healing properties. And this will result in reduction of shrinkage reinforcement and therefore lower CO2 footprint of the concrete element. We validated this with theoretical simulations on a water tank case, and the results show that it's indeed possible to significantly reduce shrinkage reinforcement. Furthermore, we have looked at the influence on rheology and mechanical properties of the concrete mix when adding our product, and the results show there's no substantial difference compared to the control mix. In order to continue collaboration with Sika and Lafarge-Holcim, we have set some next steps. For ER7, we are focusing on getting the CE marking and improving the robustness of the product, also including an EPD to emphasis on environmental friendly aspects. For the virgin concrete market, we are looking with Lafarge-Holcim's ductile applications to improve the water tightness of these products. And next to that, we are working on a tool for the acceptance of our proposition for shrinkage rebar production, which is now available and we want to introduce to the market. We are Green Basilisk and we add value to concrete. Thank you.
All right. Thank you, Jordi, for this great presentation. If you have any questions for Jordi, please put them in the chat or keep them for your Innovator demo session, of course. Next, we are absolutely thrilled to welcome Patrick Bernstein, who is the CEO of Prebona. Take it away, Patrick.
Thank you. Can you hear me?
Yes, we can.
Perfect. Prebona, we are a Swedish material tech company. We did an IPO in 2015. But international sales didn't really start until autumn 19. We have a patented technology called Prebona Compotech, developed by a Swedish professor named Professor Otterstedt, and we are today 7 employees. Now, the real fast elevator pitch, what we do, we take a silica particle at nano level, and with the help of a coupling agent, we are capable of adding active atoms onto the silica particle. The silica particle is the carrier. So everything we do and everything we have as an ingredient is silica, which is sand, active ingredients, a coupling agents, and water. Next. Now we talk about our atomic toolbox for customized solutions. And the beauty of this technology is that we can actually vary the type and combination of atoms to provide specific properties like odor elimination, like a surface protection, like antimicrobial or disinfecting of surfaces, which makes us extremely versatile. That is one way, so we can choose the atoms, but then we can also play around. We can design the amount of atoms onto the silica particles, the carrier particles. And this is really important because you can have, normally you can say the higher effect, the more atoms, the higher effect. But in medical, where we also are working, we see great effects with small amounts. And lastly, size and amount of silica particle. We work both within construction and within textile. With textile, we need a little silica, and in construction, we can then add the amount of silica to achieve specifically designed formulations for our customers. We work in 4 business areas: air care, agri-care and healthcare, and surface care. And obviously today we're only talking about surface care, where we are offering protection on surfaces for anti-fouling, mold prevention, which is in Asia extremely important, but also around Europe and all over. Dirt repellency, strengthen durability, and what's become a really hot topic since COVID is, of course, infection control on surfaces. And let me mention, at least on agri-care, in this minute, we have signed a global agreement with Syngenta, where we're currently running over 10 development projects to find solutions for their problems. Next. I will talk a lot more about this in the Innovator session. These are some long-term tests, and you see the wall in the left corner where it says washed and treated. That's an 8-year test. And when you looked at the durability and the surface protection, the design, the look of the surface, same on tiles. And it all has to do with what happens when we create our grid structure, our matrix. And again, this is something I will touch upon, but I want to make you curious for the Innovator session, and we create this grid. Next. Next, please. Now, this is something that I wanted to add in because of COVID that happened. Our products that bind extremely good to the surfaces, we can offer a sustained surface disinfection. And here you see 4 or 3 toast pieces that we have treated with a standard alcohol, untreated, and Prebona. And after 11 days, you can see this effect. It's a simple way of visualizing the sustainability or the sustained disinfection on surfaces, which could be something also for this forum. Next. So what have we achieved? Since we have opened up our atomic toolbox and we have talked to Sika, we have decided, or Sika has decided, to continue the collaboration with us and further find new solutions for the construction industry. That's really exciting. And then we managed, despite COVID, to carry out 2 tests that were positive. One of them was actually to prove what we did in our own test, that we can give a protection against pollution. And the second is about combination of water repellent and concrete as a surface treatment. And I will, of course, talk more about this in the Innovator session. And obviously, we are looking forward to as many listeners as possible so we can show what we can do. Thank you.
Thank you, Patrick, and a great teaser for the Innovator Rooms. So next, we are very excited to welcome Ricardo Rimas, who is the founder and CEO of Sonocrete. Welcome, Ricardo.
Hello, everybody. Today, I'm going to show you how we managed to get a precise and powerful technology like ultrasound out of the lab right into concrete production. We are facing a growing demand of concrete structures worldwide, but also need to reduce the carbon footprint of concrete elements. Common technologies applied like blending cements with SCMs decrease the carbon footprint, but also decreasing early age performance. And the ways of accelerating concrete applied, like increasing cement content or heat treatment, may be efficient, but not sustainable. In our opinion, there is a lack of technology able to accelerate both efficient and sustainable. Next. And this is how Sonocrete will impact concrete production. Next. The core of our technology is a cutting-edge premix device, giving concrete producers more freedom and eliminating barriers in concrete production. Next. Up to now, we are able to save up to 30% clinker in concrete, or boosting early age performance to 6 hours earlier stripping. This will, for example, increase the usage of formwork to cut costs in the production. Next. This means for a common precast concrete composition, we can increase the 12-hour compressive strength up to the 5-fold without any addition or changes in concrete composition. During the AH Accelerator, we got the chance to clarify and prove the effect of our mixing technology and derive the most important fields of application. We made huge progress in developing our business model and product to fit customer needs. We clearly see business opportunities in the cost reduction and to lower carbon footprint for concrete producers, but there are also business opportunities in the mutual development of admixtures, for example, to increase concrete performance and robustness. Very good. Thank you very much, and I'm looking forward to see you again in the more detailed Innovator session. Thank you, Jules.
All right, thanks, Ricardo, and can't wait to hear more during the Innovator session. Thank you. And for our last presentation of the day, I'm very excited to welcome Amir Kabibulin, who is the Manager of Industrial Research at Anomera. Amir, welcome. Can you hear me okay?
Yes, I can hear you. Hello, everyone.
All right, the floor is yours.
Let's go. Hello, everyone. My name is Amir Kabibulin. I'm the Manager of Industrial Research in Anomera. Next slide, please. And I'll talk a little bit about Anomera. We are a Canadian company that manufactures Dextracell, which is our carboxylated CNC, cellulose nanocrystals. We extract cellulose nanocrystals from the wood pulp. We use 100% certified Canadian forest using our very green process, which has been awarded by Canadian government. As a green, we don't use any harsh chemicals or no catalysts. We use, no, go back, please. We take the pulp and then we apply a chemical process to isolate very rigid, robust crystalline cellulose nanocrystals, which are about 100 to 150 nanometers long and 5 to 10 nanometers in diameter. They could be supplied in aqueous suspension or in a dry powder, which could be easily dispersed in water. Next, please. As I said, Anomera is a Canadian company. We launched in 2016 from McGill University in Montreal in Quebec, in Canada. We have 18 patents, international patents in 9 different patent families. We are a very scientific and innovative company, having 11 PhDs and master people. Our first target market is cosmetic products, and we have already successfully commercialized in this market. And now we're industry ready for the concrete and cement market. We're right now in the middle of building a manufacturing facility in Témiscaming in the north of Quebec, which is supposed to be launched in the second quarter of 2021. Despite all the COVID, we managed to get it through. And the annual capacity would be between 250 to 750 tons of a dry dextrosol per year. In the long-term plan, we're planning to raise an industrial factory, which will be capable of manufacturing about 4,000 tons of dextrosol per year. Although cellulose is known in the cement industry for the last 2,000 years or so, dextrosol is a bit different story. The dextrosol acts on the molecular or a nano level. The small rod-like particles of dextrosol surround the clinker particles and help the clinker hydration and improving the CSH properties, enhancing the hydration and creating a better and stronger concrete. And indeed, in our time with the LH accelerator, we managed to lower the dextrosol loading. The fact that dextrosol acts on a nano level means that you need a very, very small amount of the material to get a functional improvement in concrete. And we managed to lower the dextrosol load to just 0.03% compared to the weight of the dry cement to see the 25% increase in the compressive strength in the mortars. These are our results that we achieved with our research collaboration at the University of Sherbrooke in Quebec, and these results have yet to be duplicated in the Lafarge-Sika and Lafarge-Holcim and Sika laboratory. Excuse me. And our commercialization plan is, with the current achievements and our current standards, we're well on track. And of course, with the launch of our manufacturing facility, we're well on track for ultra high performance concrete market in 2021. And we'll also hit the oil well cement market. And with additional R&D that we need to lower the mixing share for our concrete and dextrosol introduction, we'd be ready to hit the fiber cement board and the precast concrete market. And with the further development, with all the markets taken into account, we evaluate dextrosol for about $2 billion total in the cement and concrete market. And with that, I thank you, and I'd be happy to discuss more in the Innovator session, and we'll take any questions. Thank you.
Thank you, Amir. And yes, please feel free to join him and Howard in their Innovator session. All right. Well, these were 4 really inspiring presentations. Thrilled to have been listening to that. Maybe I will start the open Q&A session, the few minutes we have ahead of us before the start of the Innovator demos, by asking our 2 experts, Robert and Ravindra, if they